Hi everyone, we're going to find the sum using the formula for the sums of powers of integers, and you should already, I'll write down the formulas for this, but I already kind of went over these in part 1. So these are the 3 problems I'm going to be doing in this order. Okay, so for the first one, we want to find the sum, and what we're going to do is use our formulas. So the first thing I'm going to do is rewrite this as the sum of n cubed going from 1 to 20 minus, I can't even write this right, the sum of n is 1 to 20. So the formula for n cubed is, let's see, let me get it out. That one's going to be n squared times 1 plus n plus 1 squared over 4, and the one for n is just n times n plus 1 over 2. Now my total number is 20, so I'm just going to plug in 20 for everything. So we get 20 squared, and this is going to be 21 squared over 4 minus 20 times 21 over 2, and if you want to make it easier, you can use a calculator. I'm going to go ahead and just multiply this by 2 and change this. I don't think I want to do that, so yeah, I'll do. So basically change this to a 4, so that way you have the same common denominator, and then you'd get 20 squared times 21 squared minus 2 times 20 times 21 all over 4. And when you clean all that up, you're going to get 43,890. You can just use a calculator. That way you only have to divide by 4 once. Or you could have just done it normally and used your calculator. Alright, the next one is this one. This one looks a little odd because of the I, but it's no big deal. So I'm going to just again break this up, and this is I equals 1. This is your index number to 6 of 6I equals, minus the sum of I goes from 1 to 6 of 8I cubed. And my formulas are with n, so I'm just going to use n instead of I. You could change these i's to n's if you wanted to. So the first formula I'll be using is n times n plus 1 over 2. And the second one, it's just like the other one, but we're subtracting one from the other. Okay, and then we also have this thing going on here. So let's see, this one's going to be over 4. And what I'm going to do to save room here, I'm going to move this over. I'm going to move the 6 in front. So I'm going to put the 6, I'll do it here. I'm going to move the 6 in front and take it out here. And I'm also going to move the 8 in front here and take it out here, because this matches my formulas better. Does that make sense? So this one's going to have a 6 in front of it, and this one's going to have the 8 in front of it. And we have a total of 6 terms, so then you just plug in your terms, and you're going to get 6 times 6 times 7 over 2 minus 8 times 6 squared times 7 squared over 4 And you clean all this up, you're going to get 6 times 21 minus 8, times 441 equals negative 3,402. Okay, the last one we have is this one, and we're going to do the same thing with this. So I'm going to break it up is the sum j equals 1 to 10 of 3, and nothing's going to happen with that, minus, now I'm going to pull this 1/2 out now before I made a mistake last time, and this is j equals 1 to 10 of j, plus, I'm going to pull out the 1/2 again, sum of j equals 1 to 10 of j squared. Now, this right here is just going to be 3. So this whole thing is just 3. Minus 1/2, and the formula for n, or j, I'm just going to use n instead of j. I'm going to put n times n plus 1. You really should probably put j, but I like n better. It's hard to do the dots on the iPad here. Plus 1/2, and the formula for the j squared would be n times n plus 1 times 2n plus 1 all over 6. So now we're going to plug in my total number of terms is 10. N equals 10 there. And so I'm going to plug everything in, and you're going to get 3 minus 1/2 times 10 times 11 all over 2 plus 1/2 times 10 times 11 times 2 times 10 plus 1, that's going to be 21 all over 6. And when you plug all that in, you should get 195, I believe. And that's all. Thank you, and have a nice day. Bye-bye.